Hello and welcome to Spiral number 2. This is the first lesson from Spiral number 2, and today we're talking about multi-step equations. So we are reviewing our algebra skills that we started with in unit or Spiral 1, and now we're moving forward to the next stage. So your goal is that you can demonstrate how to solve equations that require 3 or more steps. So what if there are variables on both sides? So we're looking at the teeter-totter model again. And in order to solve for our variable, for our value of x, we have to get all the x's to the same side. Does not matter which side we move them to. So for example, in this particular teeter-totter question here, I have one x or one group of x's on that side, so 4x's there, and I have 7x's over here. What I would like to do is I want to move all the x's to the other side of the teeter-totter. So that means that I need to take 7x's away from this side. But if you do that, the teeter-totter becomes unbalanced. So it's very, very important that we also do the same to keep balance on that teeter-totter. Because we do an inverse operation here, negative 7x and 7x will cancel each other out. And now I have all my x's on the same side. What happens from there? If I clean that up, on the one side of the teeter-totter, I have negative 9. On the other side, collecting our like terms, 4 take away 7, I have negative 3x over here. So now I have the number on one side, my variables on the other side of the teeter-totter, and we kept balance by making sure that we did the same to either side of that teeter-totter. Now we can isolate, or we can figure out that in this case, x would have to be 3. All right? So what I want to do then is come up with a general process, okay, for what happens when those variables aren't on the same side. So similar to the teeter-totter, we want all the x's on the same side. So our goal, all variables must be on the same side. All right, so that's what we want to do. We want to get all of those x terms to the same side. So again, over here, very important, we need to see this process to get full marks. I have one x over here, I have one here, but there's a constant on this side. So what I'm going to do is I'm going to move the x's to the right side. Same as what we did with the teeter-totter. It's positive 7x, the opposite is negative 7x, inverse operation. Whatever I do to one side, I do to the other. We do this because inverse operations will cancel out. I'm left with a negative 9 on this side. 4 take away 7 is negative 3x. What is the negative 3 doing to the x? Everyone's yelling at their monitor that it's multiplying. That's excellent. The inverse operation of multiplying is division. But again, whatever you do to one side, you must do to the other side. And now, those inverse operations, the whole purpose is to get the x, or the variable, by itself. Negative divided by negative, we know is a positive. 9 divided by 3 is 3. And there is our final answer. Okay? If you follow your process, those steps, you'll always get the right answer. So let's try a couple of examples here. I've got 4 examples to go through, and they get progressively more difficult. All right? First is to get the variables to the same side. So think again of the teeter-totter. So for A, 8x plus 10 equals 2x minus 8. Well, it doesn't matter which side we go. So I'm going to say, you know what? I want to move my x's to this side of the teeter-totter. And I want to move all the numbers, or the non-variables, the constants, to the other side of the teeter-totter. So looking at my green line, how do we do this? Well, I'm going to get rid of that 2x. I'm going to use an inverse operation. So the opposite of 2x is negative 2x. But whatever you do to one side, you have to do to the other. Similarly, the 10, it's a constant. I want it on the other side, opposite of the variables. It's a positive 10. To get rid of that, I have to do negative 10. But whatever I do to one side of the teeter-totter to keep balance, I have to do to the other. Now I can do a little bit of cleanup. So I have 8 take away 2x, so 8 take away 2 is 6x. I have negative 10 plus 10, so they would cancel. I have 2x, take away 2x, they're opposites, I would cancel. Negative 8, take away 10 is negative 18. Now we want to isolate or get x by itself. We ask ourselves, what is the x doing to the 6? Again, it's multiplication. The opposite of multiplication is division. I'm going to divide one side by 6, but whatever I do to one side, I must do to the other. So I divide by 6. Those inverse operations, get the x by itself. Negative 18 divided by positive 6, so that would be a negative number, and there'll be negative 3 as our answer. All right. Question B. It's very, very similar to A. All right. So I'm going to decide, and you can't choose wrong. It doesn't matter which side the x's and numbers go to. All right. So this time, I'm going to move the 2x to this side. I'm going to move my numbers to the other side. So again, inverse operations. How do I get rid of that negative 9? Well, the opposite is add 9. But whatever I do to one side, to keep the teeter-totter balanced, I have to do it to the other side. With the green, if I'm going to get rid of that 2x on that side, the opposite is negative 2x. Whatever I do to one side, I have to do to the other. So I'm going to subtract 2x. So what do I have left? I have like terms, 18 and 9. So if I add those together, I get 27. The negative 2x and the positive 2x, they cancel each other out. They undo each other. Equals 4x, take away 2x. That leaves me with 2x's. Negative 9 plus 9. Well, that cancels it out. Now I have 27 equals 2x. What is the 2 and the x doing? What operation? It is division. Whatever I do to one side, I do to the other. And you can leave it as a fraction. 27 divided by 2. That's not an even number. All right, so you can leave it as 27 over 2, or you can write it as 13.5. It does not matter. All right. Now, your upper end are the hardest questions we're going to come across. With C and D, the first thing we have to do is we want to collect like terms on each side. All right? So you want to collect like terms on each side first before we do any of the solving equations. So I ignore the equal sign. I stay on the one side. I have 3x's minus 2x's, so I'm going to collect those together. 3 take away 2, so I have 1x. The 5 has no like terms. Now I go to the other side of the equal sign, and I find I have numbers. The 8x has no partner, so it'll stay 8x. Negative 3 take away 7 is negative 10. And now I have a question that looks like A and B. Okay, so that's the only difference here. There's one extra step. I'm going to move the x's to one side. How am I going to do that? Well, I got to subtract 1x from that side. Keep that teeter-totter balanced. Whatever I do to one side, I do to the other. The numbers then, I want to move all my numbers to this side. I have a negative 10. To get rid of him, I'm going to have to add 10. Whatever I do to one side, I do to the other. So, x take away x cancels out. I have 5 plus 10 is 15. 8x take away 1 is 7x. Negative 10 plus 10 cancels out. What is the 7 doing to the x? It's multiplying. Opposite of multiplying is dividing. 15 divided by 7. Again, you can leave it as a fraction, or you can go ahead and do the division. It doesn't matter to me. And I'll just show you what it looks like. I'm just not going to put it in my calculator. I'm just going to leave it like that. All right. D is the same as C. Okay? So again, we pretend there's a wall here at the equal sign, and we collect up our like terms. So I have 2n's, 3n's plus 2n's. Those are like terms. So I have 5n equals. On the other side of the wall, I have numbers. I have a 6, I have a 7, I have a 2. So 6 plus 7 is 13, plus 2 is 15. And then that 2n didn't have a partner, so it stays by itself. Now we have a question like A part. So this time, I just have to move the variable to the other side. because there is no number on the other side. To get rid of that 2n, I would have to subtract 2n. Whatever I do to one side, I have to do to the other. 5 take away 2 is 3n equals 15. What is the 3 doing to the n? It is multiplying. Opposite of multiplication is division. Whatever I do to one side, I have to do to the other. And that leaves me with n equals 5 for a final answer. All right? So that is what you're working on today. It's keeping that teeter-totter balanced. I need to see those, the adding and subtracting on either side, because that's what we're really marking. If you have any questions or you're not sure, make sure you ask your teacher for help or explanation. Good luck. We'll see you in the next video.